So up until this point, we've covered system and out, we've covered variables, and we've covered conditional statements. You could do some pretty cool stuff with this, but you're still limited. You still don't have all of the fundamental tools you need to solve interesting problems. The next thing we're going to be talking about is what developers commonly refer to as loops. When we want to do something multiple times, when we want to do the same chunk of code, doesn't matter what it is, doesn't matter how intense it is, how complex, but we want to end up doing it multiple times. A common example that you can think of this is, let's say I want to print out 1 through 10. Now I could do this. 1, let's just do it like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. This does exactly what we wanted it to do. This is what I said I was going to do. I said I was going to print 1 through 10. However, this is nonsense. This is a lot of just copy and pasted code. 1 through 10, great, that's super simple. What if I told you to print out, 1 through 1,000 or 1 through 10,000? It gets to the point where it's so complex and so complicated that trying to make this print, 1 to 1,000 would take me an hour just sitting here copy and pasting code. There wouldn't be anything fun about it. There wouldn't be any thinking involved. It would just be copy and pasting code. So thankfully, we have the tools available for us that allow us to do this in a much simpler way. So let's get rid of this nonsense and let's take a look at a for loop. A for loop is the first looping structure that we're going to talk about, and it can look rather intimidating to start with, but once you break it down into its individual components, it's actually quite simple. So let's start out by creating a basic structure for a for loop. So I'm going to put for, and I'm going to put 2 semicolons just like that. Now, generally, as you're developing, you won't actually develop it like this. I'll show you why I want to put it this way. But this is the basic component for a for loop. This right here is technically valid code, although I recommend never ever writing this. This is called slop. This is not good code. This is bad code. What this code does is run forever. So if I put a console.writeLine in here, or let's do writeLine, and let's just print out hello. We can run this code to demonstrate the fact that it is indeed going to run forever. So I'm going to press Control F5, and you can see it's kind of hard to tell. It's kind of flickering here and there, but this is running forever. As I scroll up, it's just printing hello over and over and over again as fast as my computer will let it print. So, this is nice. This is handy. We can do it this way, but there's a much more elegant solution that we'll get to in a little bit. But before then, let's really talk about what a for loop actually is, the core components that make a for loop what it is. So in our for loop here, we have 3 sections. You can see the first section here, the second section, the third section. Each of these sections has a purpose, has a reason. They are part of the code and they mean something important. This first section is called the initialization. This initializes something to some certain state, likely something you're going to use throughout the for loop. The second section is the condition. As long as whatever condition is in between these 2 semicolons is correct, your for loop is going to continue running. Notice how nothing is there, it runs forever. That's just a way the compiler works. We're going to put something in there that'll make it stop. This last part is called the iteration. This is what changes the setting of the for loop. This iterates it over time. Now, when you look up, for loop, how to for loop on the internet, 9 times out of 10, you're going to see something like this. For the initialization, we want to create an integer 0 or an integer I and store the value 0 in it. We just want to start at 0. Like I said, as engineers, as programmers, we start counting at 0, not 1, 2, 3. It's 0, 1, 2. So that's what we initialize our for loop to start with. This is data we're going to use throughout our for loop. And remember how I said, the scope is within these 2 curly braces right here. In the case of a for loop or other sort of loops or, very few other different things, this int I exists only within these brackets. So if I was to come up here and create, another I, int I equals 0, it's going to get all upset because technically I already exists and I'm trying to recreate it. So I'm going to remove that and I'm going to keep it this way. Let's look at the second part. The second part is what is my condition? When do I want to stay? Well, our original example, I wanted to count to 10, 1 to 10. So I'm going to put I is less than or equal to 10. So as long as I is less than or equal to 10, I want to print I. Matter of fact, let's go ahead and change this to 1 so we don't print 0. So we'll count from 1 to 10. We'll be normal people at this point. Our last section is the iteration. So what you're going to do in the iteration is actually I equals I plus 1. Now there's many different ways to write this. I'll show you that in a minute. But what this says is every time my for loop runs, so every time it prints this, it's going to call this line of code. It's going to call this line of code, run it, it does what it needs to do, which in this case it increments I by 1. It then checks if this is still true, it continues the for loop. So now when we run this, it's going to print hello 10 times. Now let's not print hello, let's print our variable. Something cool about a for loop is this I is available within our scope. We have access to I throughout this, throughout this entire system right here. So I'm going to run it, and you're going to see we get the same results as before, but it's a lot nicer code. Going to my example, let's print 1 to 100. Run it. You can see I have 1 through 100 printed here. Let's do something like 1 through 10,000. Why not? Now you can see it's printing all the numbers, and it's printing so many numbers it can't actually keep up. You actually saw it doing, animation type thing. It was actually counting up there. But it actually goes through and it counts every single number. Now, previously I said there's multiple ways to write this. 9 times out of 10, a for loop is always going to increment by 1. You can increment by other things, and I'll show you that in a minute. But 9 times out of 10, well, 99 times out of 100, you're going to increment by 1. So I plus plus. This is what you generally see. The plus plus is called the post increment operator. Now you can also do plus plus I, which is the pre-increment operator, but we're not going to get too deep in those. You don't really need to know them. Just know that this, and this are all the same thing in the compiler's eyes. They do exactly the same function. So while this is going to be the most basic thing that you're going to see on a regular basis, we can do something else. We can count by 2. So let's say I want to print only the even number starting at 1. So, well, first off, I don't want to start at 1. I want to start at 0, or I want to start at 2 because I only want to print even numbers. So instead of I plus 1, I'm going to say I plus 2. Now when we run our code, we can see I've only printed the even numbers. So 2, 4, 6, 8, 10, 12, yada, yada, yada. So for loop can be really handy in that way. Let's kind of show something different here. So right now I want to count from 2 to 100, count by 2s. Let's change this back to just I++, so incrementing by 1 every time. And let's put it back to 1. So right now it's still printing from 1 to 100. Let's say I want to print from 100 to 1. I can do that in a for loop. I have these tools in front of me. I can initialize whatever my starting state is, my condition to continue, and how I'm going to iterate through the problem. So I want to start at 100. I want to continue while I is greater than or equal to 0. 1, sorry. And then just like we have I++, I minus minus is also the post decrement operator. So we can decrement. So now when I run it, you can see that it counts backwards. It starts at 100 and goes down all the way to 1. Now, out of all of the for loops I've written in my life, probably maybe 0.5%, maybe less than that, have actually been decremented. There's times where you want to do decrement for loops. For example, we want to count from 100 to 0. We want to do a countdown, something like that. Another time is when we get to lists and things like that during the semester. If you want to remove an element from the list, you have to iterate through it backwards. Otherwise, you run into index out of bounds issues, which, we'll get to that later. So I've gone ahead and written what I call very, very, very terrible code. You never want to do anything like this. I just want to show that it works. Get it in your head so that you think, there's a right way to code and a wrong way to code. So in this scenario, I create a Boolean called isFinished. I default to false, and I default to 0. I put I up here instead of putting it right here. Perfectly valid. The compiler isn't going to get mad at me for that. The compiler is perfectly okay with that. but it's ugly. It's an extra line of code that you don't need. I'm going to print to the user, type hello. The exit condition is to print hello, or to type hello, sorry. Our condition to continue the loop as long as is finished is false. So remember, we initialized is finished to false. So it's going to come down here and just run. And then notice how in our iterator right here, I put a console.writeLine statement. Now, if you remember, I++ actually increments the value of I. It actually takes the value and changes it. So in this scenario, we're going to go in here and print this attempt number whatever I is at the time, 0, 1, 2, 3, so on and so forth. In our for loop body, we're going to take the input. If console.readline is hello, then we're going to set finish to true. It's going to say checking input again. It's going to then check this condition, which at this point it will fail, and it'll come out and it'll say the input was correct. So let's go ahead and run it. You know, again, from a user standpoint, this problem looks fine. It looks like it works correctly, but it's absolutely terrible on the implementation. So if I just type random numbers, you know, I'm failing miserably, I don't know how to type, yada, yada, yada. You know, get to all these attempts. Attempt 26 was a failure. So I'm going to go in and I'm going to print hello as it asks me to. It says checking input attempt number 27. That was correct. So it says my 27th attempt was correct. But again, this code is ugly. This code is not clean. You don't want to write this in any software period, whether it's professional or academic or whatever. You never want to write code like this. So much so, let's delete that monstrosity. I want to show you a cool trick, and Visual Studio has a lot of cool tricks like this. I've skipped over some of them, but check this out. You know, if I was to write a for loop, and I'm a pretty fast typer, you know, I know how to type code like I know how to type English. I type it really quick. If I was going to make a for loop, I would go for int I equals 0, I is less than 10, I++. So I'm very good at typing this. Those keys fall naturally under my fingers. But this is so common. This kind of structure is so common in programming that Visual Studio gave us a shortcut. I'm going to type for tab tab. It's going to automatically fill it out for me. Check that out. I'm going to press tab again. It's taking me to length. I'm going to take this to 10. Done. So compared to what I did before, I'm going to write it out again. We're going to do for int I equals 0, I is less than 10, I++. Okay, cool. Ready? You know, that took me a few seconds. Ready? For tab 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 10. Literally that easy. C# does so many cool things for you, and as the semester goes along, you know, we'll kind of take a look at the really cool things that you get to see in this software, Visual Studio and C#, because it writes your code for you. It's kind of neat, right? So for loops are very good when you know the starting condition and the end condition. A lot of situations you don't know the scenario. You know, we could do something janky like I had previously with a Boolean and have input saying, do you want to stop or do you want to continue? And, you know, type until we say stop and then it stops. But that's ugly. It's messy. That's not what a for loop is for. That's where we get our other versions of loops, a while loop. So a while loop is going to be very similar. It's going to have an empty, or it's going to have a value that goes in here, a condition that goes in here that determines when to continue, when to stop. So something you might see often, even though it's bad programming practice, while true. This code will run forever. But I don't like this. I want to try something a little bit different. I'm going to say int input, and I'm going to default to 0. And I'm actually going to make this a string. And I'm going to default it to the empty string. I'm going to say while input does not equal stop. I'm going to do this. So let's create something in our while loop to do something interesting. Let's have it continue counting on every key press that isn't stop. So I'm going to say input equals console.readline. If console.readline, or oops, sorry. But yet, let's just do this. We're going to say input equals console readline, and then we're just going to print out, are you finished yet? And then down here, we're going to say, cool, you're finished. Now, when I run this code, It's going to show just an empty box waiting for my input. So I'm just going to put random stuff. It's asking me, are you finished yet? Are you done? I'm just mashing on the keyboard. Are you done? Are you done? Are you done? Eventually, I'm going to get to the point where I am done, and I want to say stop. Cool, you're finished. It's going to realize that I've put in the exit condition. It's not going to continue anymore because input now equals stop, which makes this condition right here that I've highlighted incorrect. This is now incorrect, so it's no longer going to continue with the while loop. It's going to break out of the while loop and go to the next section. So sometimes when you're programming and you need a loop type structure, you always want to run at least one iteration of the loop once. That's what I've kind of done here. Let's say, up here I had a whole bunch of code, yada, yada, yada. There's all sorts of stuff up here. Just imagine that. What happens if input happened to be stop as I got to my while loop? It wouldn't run at least once. Or better yet, let's do something like this. Let's initialize it here. Let's put another while loop right here. And then we're going to say, are you really at it again? So here we go. So what's going to happen here is it's going to get to this line. It's going to set input equal to nothing, the empty string. And then this while loop right here is going to continue as long as input does not equal stop. As soon as I give the stop command, it's going to stop this while loop. It's going to say, cool, you're finished. And then, you want to try this other while loop, are you really at it again? Are you really just spamming again? But this condition right here says while input does not equal stop. So if I go ahead and run my code, so are you finished yet? Are you finished yet? Are you finished yet? I'm going to say stop, and it's just going to close my program. I can't, I can't do anything yet. This while loop did not run simply because its condition is the same as the previous. So somewhere else in my code, I set the condition for the while loop to actually run to false. So it never actually runs once. Now, to remedy this, as developers, we have developed what we call a do while loop. As opposed to a while loop, it's a do while loop. A do while loop is always going to run the contents of the loop at least once, which is very handy in many situations, and I'll show you another example of that here in a minute. But let's go ahead and do that. So I'm going to cut this, I'm going to put it at the end and put a semicolon after it, and put a do at the top. So now when we run our code, because remember, this is always going to run at least once. So as I run my code and bring it over here, I'm going to mash, mash, mash. Are you finished yet? Are you finished yet? Are you finished yet? All right, I'm done. Okay, cool, you're finished. And then I'm going to keep going, and it's going to say, are you really at it again? Yes, I'm at it again. Are you really at it again? It keeps asking me. So I'm going to press stop again, and now it's going to close my program. It's going to halt the program. It's going to get to this bottom line down here and stop. I'm going to press any key. It's going to close my program. So now let's take a minute to show something really practical with all the tools we've learned thus far. So something that you saw me doing in our previous examples was I would run some code, put some input, it would close. Run some code, put some input, it would close. What if I want to run 100 iterations of some input? For example, let's say I have an integer input, and I'm going to initialize it to 0 for now, but I'm going to say console.writeLine, how many times, or let's do it this way. What number do you want to print up to? I'm going to come down here and put a semicolon. Input equals int.parse console.readline. So I'm asking what number I want to print up to. So for tab input. So I want to count up to this number. Now keep in mind, this will only be true for up to the number before input. So if I want to count from 0 to 100 and I input 100, this right here would only do up to 99. You have to put this equal sign in there to make it run that one extra. And this is somewhere I see a lot of beginner developers kind of get stuck. So remember this, try to watch out for this. So we put input in here, we're good to go. So now console.writeLine, and I'm going to say input. I'm just going to count to input. Now run the code, and this is what I was talking about. So what number you want to print to? I'm going to say 24. It's going to go, oops, it printed input. I need to print I. That was a mistake on my end. Let's run it again. What number do you want to print up to? 24. 0, 1, 2, 3, 4, yada, 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 24. So it's going to do exactly what I said it to. But now it's just going to stop. You know, what if I'm practicing counting or something like that? I don't know. I want to run this multiple times. Well, I can go ahead and take all of this code and put it like this. Now, we need some condition to exit. Let's create a string s input, and we're going to initialize that to the empty string because we haven't input anything yet. And we're going to say, well, s input does not equal stop, just like we did in our previous example. But down here, I'm going to come and say console.writeLine, do you want to continue? Let's actually change this up a little bit. So I'm going to say, do you want to continue? Yes, comma, no. And we went into depth on how to solve this problem. So let's go ahead and do that. So we're going to say s input equals console.readLine. And we don't even need to handle s input right now. We're going to handle the input from the user in the while loop. So instead of this, we're going to consider the yes or the no. So we want to continue as long as our s input is yes in some way, shape, or form, you know, aka the first character of input should be a y. So let's go ahead and do that. Remember our or here. So this right here encapsulates pretty much every type of input the user could have for yes as an input. So when I go ahead and run it, what number do you want to print up to? I'm going to say 5. 0, 1, 2, 3, 4, 5. Cool. Do you want to continue? Sure. What number do you want to print up to? 10. 0, 1, 2, 3, 4, 5, yada, yada, 10. Do I want to continue? Yes. What number do you want to print up to? 3,000. And it's going to go all the way up to 3,000 and it's going to ask me if I want to continue. I'm going to say no this time, but in reality, I could put anything that is not a y in here to stop. So I'm going to say 2. Do I want to continue? G. You know, it is going to eventually stop, and this is kind of a design flaw. It should, you know, come along the lines of saying, you know, incorrect key or something like that. You know what? Better yet, let's do that. Let's take the input and determine if we want to actually continue or not. So we're going to say if s input 0 does not equal y, because we're checking all of our values. So I'm actually just going to copy this, put it in here, or s input 0, not null, n, or s input 0 does not equal capital N. So if it doesn't equal any of these, we're going to say console.writeLine invalid input. Okay, so I've put this in here. Let's try this. Let's do another do while loop. And remember, I'm doing a do while loop because I want it to continue running. I want it to run at least once, and I want it to continue based on the given condition. And the given condition in this case is, sorry, we actually need to change this up a bit. So we're going to go back and we're going to change this. So instead of doing like I did previously, I'm going to change it to this. If it's not equal to y. Okay, so if it's not equal to any of these, we're going to go through and we're going to say it's an invalid input. Thankfully, though, we want to continue running this code here with this do while loop if this condition is true. So therefore, I could just copy paste it in here, put the semicolon, and we're good to go. Now, this is some pretty sloppy, ugly code, but it kind of gets across the point on what while loops can do, what while loops, for loops, things like that can do. Plus, this is putting a whole bunch of things that we've learned thus far together. You know, we have conditional statements, we have variables, we have all sorts of fun stuff in here. So now I'm going to run it. What number do you want to print up to? 5. I don't want to continue. G. Invalid input. Do you want to continue? I said G. Invalid input. So it's going to continue telling me I'm wrong and ask for a real input. Do I actually want to stop? Yes, I want to stop. It's going to go to the end of my code and it's going to say, do you want to continue? Now I can also go up here and continue what we did before, where I want to print 5. Do you want to continue? Yes. What number do you want to print up to? 6. And continue using our code. So while this is kind of like a sloppy mess, it does what it needs to do. We have multiple loops, some even nested within other loops, to form an interesting sort of problem. I'll give you a very, very minute interesting problem. So for your final project, for your final assessment, you're going to have to do something similar to this. So let's kind of show what that process looks like. So first off, I'm going to delete the bulk of this. I'm going to have s input as the string, and I'm going to remove this content. So what your code is going to do for your final is it's going to give you the user a menu. So the menu is going to look something like this. We're going to say 1 for do this thing, and console.write line 2, do that thing. So we're going to allow the user to input a value 1 or 0, or sorry, 1 or 2, based on what they actually want to perform. And now let's change this to an integer and change it just to input and change this to 0. Just default to 0, it doesn't matter what it defaults to, it's all fine and dandy. But we're also going to add console.writeLine exit program. We're going to give the user the ability to exit the program. So because we know 3 is the exit condition, we're going to say if input does not equal 3, we want to continue. Remember, this right here is a Boolean expression. This will equal true or false. Does input equal 3? If it does equal 3, this is going to return false because of the not equals here. So we're going to go here and we're going to say if, well, let's go ahead and demonstrate this as is real quick. I need a console read line in there first. Input equals int.parse console.readline. So we're going to read in user input, we're going to parse it into our integer, we're going to store it in input. So we're going to get this. Please enter a value for the following. 1, do we want to do this thing? 2, do we want to do that thing? Or 3, we want to exit the program. So I'm going to press 2, and imagine I did something, and then it comes back to the beginning, comes from here, goes back up to the top, and comes here and prints out the menu again. So I did 2 last time. Let's do this thing this time. Same thing. Now when I press 3, it's going to go down to the bottom of the program. It's going to leave. It's going to say press any key to continue. You know, common courtesy says to thank your user for using your app. So console.writeLine, thanks for using my program. Sweet, straight to the point, easy. So now let's use an if statement in here. So if input equals 1, we want to do something. Specifically, we want to do this. Else, if input equals 2, we want to do that. You know, let's say this is print 10, and this one is say hello. Something like that. We want to do these. So this one is going to console.writeLine 10. And this one is going to console.writeLine hello. And now, just for my sanity's sake, just to keep everything kind of neat and pretty, I'm going to put another console.writeLine here to separate the different iterations of the loop. So enter a value for the following. So I want to print 10. It's going to print 10 and then it's going to put a space there. That's what this extra console.writeLine does. It puts that gap there. Say hello. It's going to print hello. It's going to do the following. When I press, and you know, I can, oops. I mean, I could fail miserably and it'll just continue running. But you can see when I press 1 and 2, it'll go forever doing exactly what I ask it to do until I press 3, at which point it'll say, thanks for using my program, press any key to continue. I could close the program. So this is the bulk not really the bulk, but this is a good chunk of what your final assessment is going to look like. It's going to ask for a menu, 1, 2, 3, 4, 5, 6, 7, 8, yada, yada, yada. And then it's going to go through. Your actual logic is going to be in these statements here, these conditional statements. It's going to be a lot more interesting than print 10. It's going to be, do what the actual problem asks, which is going to be a few more lines of code. But this looping menu allows me to stay in the program. Let's say you were to do something like this. Oops. So let's say you didn't use the while loop. Let's just say you had something like this. This works, but it's ugly. Let me actually run that on your screen. Please enter a value for the following. 1. Thanks for using my program. I'm like, cool. Well, I wanted to print hello now. So, okay, so I got to restart the program, bring it back over here. Now I want to do 2. Okay, cool. Having this while loop in the way that it was structured before, like so, is a really nice way to let your users interact with your program. User-centered designs. Think of it that way. So I'm going to leave this video here specifically because our next video has to deal with arrays. And arrays are the perfect tool to use for loops for, or any sort of loop for that matter. An array is a collection of elements, so we're going to use a loop to go through each individual element and see what it is. See, print it out, do something with it, sort it, interesting things like that. So look forward to that in the next video.